welcome back to Lesson 2 in Week 4. The learning objective for today is, can I understand what pitch is?
Talk to your partner. Can you remember how sound is made? Remember, you can pause the video and play when you're ready to find out the answer. That's right, sound is made when objects vibrate. The vibrations make the air around the object vibrate and the air vibrations travel into your ear. Talk to your partner. Which statement is correct? A. Sound can travel through liquids. B. Sound can travel through solids. C. Sounds can travel through gases. Or D. Sound can travel through liquids, solid and gases. That's right, D is correct. Sound can travel through solids, liquids and gases. However, sound travels through some materials better than others. In Lesson 1, many of you may have carried out the experiment. Why did the grains of rice vibrate? Well, you would have seen the grains of rice vibrating on the cling film. This is because sound is created by vibrations. These vibrations travel through the air as a sound wave.
Talk to your partner. What does pitch mean?
Pitch can be high or low. A high-pitched sound is like chalk screeching on a blackboard, and a low-pitched sound is like a rumble of thunder. The pitch of a sound tells us how fast the sound vibrated when it was first made. A low note will have a slow vibration and a lower frequency. A high note will have a fast vibration and a higher frequency. You can make a string on an instrument have a high pitch by shortening the string or making it tighter.
Sounds can be high-pitched, like the squeak of a mouse, or low-pitched, like the roar of a lion. But what is it that makes these vibrations different? This explorer is wearing special goggles. They let him see sounds in the air all around him. The sounds he sees are like waves. Some of them are tight, squiggly waves, like this. A drum with a very tight skin makes this sort of wave. It's what we call a high-pitched wave. And some of the waves are long, loose, rolling waves, like this. A drum with a loose skin makes this sort of wave. It's what we call a low-pitched wave. Excuse me. I think maybe you need to take the glasses off. You're about to walk in. Oh, too late.
So we now know that pitch is a measure of how high or low a sound is. The whistle being blown creates a high-pitched sound. A rumble of thunder is an example of a low-pitched sound. You can see the waves. The faster vibrations equals a higher pitch, and the slower vibrations equal a lower pitch. You can change the pitch of a sound in different ways depending on the type of instrument you are playing. For example, if you are playing an xylophone, striking the smaller bars with the beater causes faster vibrations and so a higher pitched note. Striking the larger bars causes slower vibrations and produces a lower note. High-pitched sounds are made by fast vibrations. Smaller, shorter, thinner, tighter and denser objects have more high-pitched sounds. Low-pitched sounds are made by slow vibrations. Larger, longer, thicker, looser and less dense objects make more low-pitched sounds. Which object will make the lower-pitched sound? Why do you think? Talk to your partner.
Piercing pitch and volatile volume. All sound waves have a pitch and a volume. Pitch describes the frequency of the sound wave. Frequency is how close together each sound wave is. A low-pitched sound, such as a sound made by a bass drum, has a lower frequency than a higher-pitched sound, like that of a penny whistle. This means that the sound waves coming from the bass drum are farther apart than those in a penny whistle. The frequency of sound waves is measured in hertz. Humans can hear sound waves travelling at a frequency between 20 and 20,000 hertz. Dogs can hear between 67 and 45,000 hertz. Dog whistlers make a sound above 23,000 hertz. Dogs are able to hear sounds at this frequency, but humans are not.
For today's lesson, you will be carrying out your own experiment. You will need a selection of clear glass bottles or plastic bottles, coloured food dye. Step 1. Pour different amounts of water into a selection of glass bottles, but don't fill any right to the top. Add different coloured food dyes to the water so you can see the levels more easily. Rest the neck of the bottle on your lower lip and blow gently across the top until you hear a note. Blow gently across all the bottles. Do different levels of water make different noises? Blowing makes the air inside the bottle vibrate, producing a note. The notes change according to the amount of water and air in the bottle. The bigger the space between the water and the top of the bottle, the lower the note. Try tapping the bottles instead of blowing. What happens? Tapping makes the water vibrate. The more water there is, the lower the note. Activity 2. You can have a go at making your own instruments using some random junk model from your house, such as a tin with a bit of plastic and some elastic bands, or an old tissue box with some string and a little bit of sellotape. Here is your challenge for your junk instrument making. It needs to be able to produce at least 3 different pitches. Can you design it so that its pitches increase in order? And can somebody else play your instrument? Have a go, have fun and enjoy. Remember to take a picture and upload your work to Tapestry or send it to the Year 4 email address. I hope you enjoy your activities, have fun and keep safe.